Okay, students, we go on to question number 6. So let me write question number 6 down here. The coefficient of 1 over x in the expansion of 2x positive a over x raised to the power of 5 is given to be a 720. Now what they are asking us is to find the possible values of the constant a. And next one is find the coefficient of 1 over x raised to the power of 7 in the expansion. Okay, so this is a binomial term. So let me go to the next page and do this question. So solution, we know the binomial expansion to be as a positive b raised to the power of n is equal to sigma nck and a raised to the power of n minus k and b raised to the power of k, and k is stretching from 0 to n terms. Now for given, what is given? 2x positive a over x squared raised to the power of 5. I just want to make sure I place x squared here. Okay, so this is x squared. So for this is going to be sigma k is equal to 0 to 5 and 5ck times 2x raised to the power of 5 minus k times a over x squared raised to the power of k. Now consider the term 5ck times 2x raised to the power of 5 minus k times a over x squared raised to the power of k. Now this is equal to 5ck times, I am writing this as 2 raised to the power of 5 minus k times x raised to the power of 5 minus k times a raised to the power of k divided by x raised to the power of 2 raised to the power of k, that's 2k. Now move this to the numerator. So this is equal to 5ck times 2 raised to the power of 5 negative k times x raised to the power of 5 negative k times a raised to the power of k times x raised to the power of negative 2k. Now club these two together. So this is equal to 5ck times 2 raised to the power of 5 negative k times a raised to the power of k times x raised to the power of 5 negative k negative 2k. Why do I write it like this? Because a raised to the power of m times a raised to the power of n is a raised to the power of m positive n. So this is going to be 5ck times 2 raised to the power of 5 negative k times a raised to the power of k times, you add these two together, you get x raised to the power of 5 negative 3k. Okay, so this is what we have got. Now they are asking us to find the value of a, right? But they have given us the following. So what is that they are given that the coefficient of 1 over x is 720. Now this is the nth term. Okay, now what I'm going to do is I want to collect the coefficient of 1 over x from here. So let me use another page. So given, what is given? Given that the coefficient of 1 over x is equal to 720. Also, the nth term, we have evaluated the nth term is 5ck times 2 raised to the power of 5 negative k times a raised to the power of k times x raised to the power of 5 negative 3k. Now 1 over x means, we know that, what do we know? We know that 1 over x is equal to x raised to the power of negative 1. This would mean we would collect the coefficient of x raised to the power of negative 1, which is got from the nth term. How? By setting, you see here, by setting 5 negative 3k is equal to negative 1. So this means you push the 3k to the negative other side, you get positive 3k. You push this to this left side, you get 5 positive 1. So 6 is equal to 3k. Therefore k is equal to 6 over 3, which means 2. So k is equal to 2. We've got the value of k to be equal to 2. So having got that value, therefore the nth term for 1 over x is going to be, instead of saying nth term, I would say the term for 1 over x is going to be what? 5c2 times 2 raised to the power of k is 2, right? So it's going to be 5 negative 2. I'm utilizing this the above value. So a raised to the power of 2, k is 2, and x raised to the power of 5 negative 3 of 2, right? And what is this 5c2? Okay, before that let me simplify these things off. So this is equal to 5c2, 2 raised to the power of 5 negative 2, that's going to be 3. This is a squared, and this is x raised to the power of 5 negative 3 times 2 is 6, negative 1. So this is what we have got. Now what is the next step? I will have to actually do 5c2. Okay, 5c2 also 5c2 is what? 5 factorial divided by 5 minus 2 factorial times 2 factorial. So 5 factorial is 5 into 4 into 3 factorial. 5 negative 2 is what? 3. You have a factorial there and you have a 2 factorial there. So 3 factorial gets cancelled. 2 factorial is 2. So 2 divides here 2 times. 5 times 2 is 10. So therefore what have you got? You got 5c2, right? 5c2 times 2 raised to the power of 3 times a squared times x raised to the power of negative 1 is now equal to 10, 2 raised to the power of 3, that's 8, times a squared times x raised to the power of negative 1. So therefore the coefficient of x raised to the power of negative 1 over here is 80 times a squared. But in the question, okay, this is working, it has spilled over. But in the question, what do we have? The coefficient of x power negative 1 is 720. So this means 80 a squared is equal to 720. Cancel the 0, cancel the 0. So a squared is equal to 720 divided by 8. 8 divides here 9 times. So a squared is equal to 9. Therefore a is equal to root of 9, which means a is equal to plus 3 or minus 3. You will have to state the plus or minus. So that's a value. It's quite a sum and it's really a nice one. So let's move on to the next part. Now the next part is part B. We have to find the coefficient of 1 over x raised to the power of 7. Now we know the nth term. We know the nth term. So what is the nth term we know? Go back and get the nth term. This is what we have got. So write that 5ck times 2 raised to the power of 5 negative k times a raised to the power of k times x raised to the power of 5 negative 3k, right? But I'm going to take the value of a to be equal to 3. I think that is fair enough, right? So you can take the value of a to be equal to 3 and make the substitution. So just substitute there. Now you need this x raised to the power of 7 in the denominator. So this means 5 negative 3k is equal to this, it will become negative value, right? So you place the 7. So this means move this 3k to the other side. So it's going to be 5 positive 7 is equal to 3k. Therefore k is equal to 12 over 3. 3 divides 12 4 times. So this means k value is found. K is equal to 4. So if I were to take this as say sum 4, so therefore 4, therefore my 4 is going to be equal to 5c4 times 2 raised to the power of 5 minus 4. A is 3, so 3 raised to the power of 4 times x raised to the power of negative 7. Right, this is going to be negative 7 clearly, because k is 4, you substitute there and that's going to be negative 7. So calculate the coefficient. So 5c4, so this means 5c4 is 5 factorial over 5 minus 4 factorial times 4 factorial. 5 factorial is 5 into 4 factorial. 5 minus 4 is 1, you got a factorial there. 4 factorial is there, 4 gets cancelled. 1 factorial is 1, so you get 5 there. So this is equal to 5 times 2 raised to the power of 5 negative 4, that's going to be 2. Now 3 raised to the power of 4, 3 into 3 into 3 into 3. 3 3s are 9, 3 3s are 9. So 9 multiplied with 9 you get 81. So you have 81 there. And x raised to the power of negative 7, you don't have to place that. So you can just simply say therefore coefficient of x raised to the power of negative 7 is equal to 5 times 2 is 10. 10 multiplied with 810 will give you 810. So therefore coefficient of x raised to the power of negative 7, which is also 1 over x raised to the power of 7, is equal to 810. So that completes the solution for this question. We move on to the next one.